So today we're going to do a review, and we'll be pretty much very roughly review and use our review question 1. And the real examination question and will be very similar to that. Some of them even will be the same. I just moved it there because I want to see whether you're spending time to do. Okay, if you're spending time to do, that is good. Exam 1 review, I always want you to do is that there's a bunch of the question there. You could be group them and then find the answer and go back to read the slides, and then you can get the conclusion what are those questions really test you for. Now, by the way, tomorrow, sometimes in the afternoon, one of my TA, Carly Long, will do a additional review section if you need help. So tomorrow, Wednesday afternoon, somewhere in the lab room, you can come. It's just an open section. If you want to come, she will do an additional review for you if you have some additional questions. Okay. I basically use this material to help you do the review. Same as difficult level. For exam 1 review, I always want to start from Gram-Stain, because we did a lot in the lab, and you've already been very familiar with Gram-Stain. Then we talk about all the questions related to that. So we know Gram-Stain steps is crystal violet. So what's the function of the crystal violet? It is a basic dye. Okay, then the second step is we're going to use gram iodine because it's a mordant to make the stain strong. And then we use 95% alcohol. What's the function for that? Is for decoloration. And then the last step is saffroning, and we will say it is a counter step. And therefore, based on cell wall theory, basically is talk about the peptidoglycan, and based on the lipid theory, based on the amount of the lipids, basically decided by lipopolysaccharides, we know the results of what it looks like. Is gram-positive bacteria is purple color, and the gram-negative bacteria is pink. Okay, so that is a basic information about the Gram-Stain, and it is actually answers a question at 21. Okay, and let's say the Gram-Stain procedure, briefly explain the function of each steps. That's we finished. Now we're going to go back to see some of the other questions which is related to the Gram-Stain. Okay, then we want to talk about that. Okay, which one? Let's look at question number 17. And I need some reaction from you guys, and basically I'm assuming you already did, or you already at least see some questions. Okay. Question 17. If the decolorizer, which is alcohol actually, is left on too long in the Gram-Stain procedure, gram-positive organism will stain what? And the gram-negative microorganism will be stained what? So this is a question asked you. This step is too long. What's going to happen? Now, to this question, I always make a joke. Okay, somebody is doing the Gram-Stain, do the crystal violet, the gram iodine. Then the girlfriend is calling, says something happened. Can you come? Then he dropped some 95% alcohol. Then come back after 4 hours. What's going to happen? It's all going to wash off, is that right? So, gram-positive organism will be stained. Well, of course, you're going to have to do the saffron. Okay, come back with the saffron. What happened? We'll stain pink, is that right? How about the gram-negative organism? We'll stain pink too. Because the decoloration is too long. Think about it, 2 hours, 3 hours, 4 hours, it's all washed off. Okay, that's another possible reason we'll call gram variable stain. Now, one of the other reasons we'll call variable scan is use older culture. Is that right? We'll call gram variable scan. Okay, so that is the question for that. Now let's look at, do we have any other questions related to the gram scan? Let's take a look. I don't know about that, I just take a look, okay. Oh, we may not have it, so that's good. Okay. Then we mentioned this guy, lipopolysaccharides. Because of the lipopolysaccharides, so gram-negative bacteria have a high amount of the lipids. So question 29. The lipopolysaccharides that is found in the outer membrane of gram-negative bacteria is also known as, and I said that the LPS is for gram-negative bacteria, let's say Salmonella, E. coli will be a problem, will be an issue, because it will generate a toxin. What is the name of the toxin? It will generate endotoxin, is that right? And this toxin is actually heat liable. So what this means, when you heat it, the bacteria will be died. That is what we call the food infection. So lipopolysaccharides, the major toxin will generate is endotoxin. Okay, so the answer of this one is D. Yeah, then let's find the other question which relate to the gram scan. We didn't find anything right here. Okay. Remember cell wall theory and the lipid theory, and we draw on this picture right here. In my second lecture, we draw the picture of the gram-positive bacteria and gram-negative bacteria. Then we have this big question, 34, which is a labeling. Can you do a label? Now, if you say you don't know, what are we going to do? We're going to go back to see the slides. Okay, that's what we learn. We go back to see the slides. I believe it is lecture 3. Okay, we go back to look at the slides. If you forget, go back to do it. That's what you learn. Okay, it's not have a piece of paper, then remember this is A, this is B, this is C. That's not what you learn. If you forgot, go back to see the slides right here. This is gram-negative cell wall. And this is gram-positive cell wall. So you can take a notes on the side of this question. This is correlated to lecture 3, slides 16 and 17. And when you study the gram-negative bacteria, don't forget to study gram-positive bacteria. It's the same thing, okay? So let's take a look at these questions. What are really for? It's off. Question, we're going to have to open it again. Okay, let's look at that label question. First of all, you need to write on the side, is this gram-positive or gram-negative bacteria? So see, terms you may need to use is gram-positive, gram-negative, outer membrane, inner membrane, peptidoglycan, lipopolysaccharides, periplasma, transmembrane protein, teichoic acids, cytoplasma, phospholipids, label hydrophilic and hydrophobic ends. So, where we should do? First of all, is this gram-positive or gram-negative? It's gram-negative bacteria. Okay, that's the first thing you do. Therefore, when you do here, gram-positive bacteria, you could cross it out. Okay, then you label gram-negative. Of course, you're going to have to write here. Okay. Outer membrane, where is the outer membrane? It's right here. That is the outer membrane. Okay, this whole section is the outer membrane. This is inside is inner membrane. Okay. Okay, inner membrane is outer membrane is on the top, inner membrane is at the bottom. Okay, I can only show you. Where is peptidoglycan? It has it very thin, right here, right in the middle. Very thin. That's peptidoglycan. Okay. Where's lipopolysaccharides? Of course, outside. These are extruded areas. That's lipopolysaccharides. Okay. You can just label these lipopolysaccharides on the top. Periplasma. What is periplasma? You can label the whole thing as a periplasma. Maybe right here. Okay, periplasma, the whole thing. That's a periplasma. Transmembrane protein. What's that? Right here. That's transmembrane protein. Okay, that's for transferring nutrients. Teichoic acid, we don't have it. We don't have teichoic acids because that's for gram-positive bacteria. Remember, gram-positive bacteria has teichoic acids or lipoteichoic acids, heavy peptidoglycan. They don't have gram-negative bacteria. They don't have that. Okay, cytoplasma again. Well, it's the same thing. Phospholipids. Do you still remember two ends? This you have to clear label. Hydrophilic. This here. Hydrophobic. Okay. So that was the label. If you don't know about this, then go back to look at your slides right here. Okay. Plasma membrane. Right here. Plasma membrane, outer membrane cell wall structure. Okay, that's a gram-negative bacteria. We're going to talk about this question. Okay, so that's a gram stain. We have some question related to that. Now, we want to go back to see some of the questions related to the staining technology. Because in this class, we're spending lots of time in the lab to talk about staining technology. So we talk about the simple stain, we talk about the gram stain, and we talk about the endospore stain. That's what we did in the lab. We talk about the acid-fast stain, flagella stain, and the capsule stain. So these are some of the questions related to that we need to take a look. Okay, let's look at some questions. Question 18. Basic dyes such as methylene blue binding to cellular molecules that are. And we talk about in the classroom, bacteria grow 24 hours, it will be negatively charged. And all those basic dyes, they are positively charged. That's why they could be combined together. So what is the answer for this one? Basic dyes such as methylene blue binding to cellular molecules that are negatively charged. Is that right? There's a B, negatively charged. And the methylene blue is positively charged. That's why they can combine together. Okay. That's question number 18. Okay, let's look at this one. Question number 16. Acid-fast organisms such as Mycobacterium tuberculosis contain constructed from mycolic acids in their cell wall. Okay, acid-fast stain. We mentioned about because of the mycolic acids, it generates a very waxy cell wall. That's why basic dye cannot go inside. We need to use acid-fast stain. What is the stuff really for mycolic acids? It is an unsaturated fatty acids. That is called nucleic acids. So what is the answer here? Is that a protein? No. Is that a carbohydrates? No. Is this a peptidoglycan? Of course not. Otherwise we can do gram stand. So what's the answer? It's lipids. Okay, unsaturated fatty acids, in other words, it is lipids. So the answer here is C. Okay, let's look at question 15. This is related to the first step of all these STEM, and we talked about in the simple STEM already. Question number 15. Prior to staining, smears of microorganisms are heat fixed in order to allow eventually visualization of internal structure, of course not. Ensure removal of the dust particles from the slide surface, not. Attach it firmly to the slide, is that correct? Yes, that's correct. Attach it firmly to the slide. So the answer is C. Create small pores, that's not correct, because the answer is C right here. Okay. Some other questions right here regarding microscope use. We all could be talk about that. Now don't forget, there's another topic for all of these same technology. Before that is microscope. Microscope use. We talk about several microscopes: light field, dark field, laser confocal, fluorescence microscope, and electronized microscope, or electron microscope. So some questions here are relatively easy. There is a 30x objective lens and a 20x ocular lens have a total magnification. What is the answer? It should be quick, is that right? Magnification we do 30x multiplied by 20x equals 600x. It's a very simple question. So the answer is D, 600x. Second question. A microscope that exposes specimen to UV lights, ultraviolet light, UV light, or blue light, and forms an image with the light emitted at different wavelengths is called. And when you do this question, you need to know this is asked you about the energy resource. So is that a phase contrast microscope? Of course not, because phase contrast light microscope is still using normal light as an energy resource. So it's not it. Is that a dark field microscope? Of course not. They use light as an energy resource. Is that scanning electron? No, they use electron as an energy resource. So what is the answer? It's a fluorescence microscope. And where you gonna find this one? Some of you confusing, you didn't know the answer, so what we do? We go back to look at the slides again. Okay, the slides will be right here at our lecture 2. This is the answer is when you use fluorescence microscope at the very beginning at the top, exposes specimen to ultraviolet, violet, or blue light. And that is where the answer comes from. So majority of these questions you can see is from the slides. They're not really very difficult to understand. So that is something we talked about. Okay. Good, let's talk about something else. Confocal microscope, in combined with the specialized computer software, can be used to create 3D images of the cell structure. Is that true of us? Yeah, it's true. Laser confocal microscope, the good thing is to do the observation of the 3D images, and it's specifically for one group of the bacteria. It is a matrix on the surface. We call them biofilm. And we just talked about it from last Thursday. And I believe there is a question for that. So you could go ahead to find it. Where is that question? Okay. Somewhere there is a question for that. Let's see whether we can find it. Somewhere here. Okay. Look at question 48. Complex microbial communities. Question 48. That grow tightly adhered to the surface or core. It's called a biofilm. And when you do this answer, you see the biofilm, and at the side you put to the right, laser confocal microscope can do the observation to see the 3D images. Now, what is the other microscope can see 3D images? It is scanning electron microscope. So, how you study it? Biofilm. Okay, we want to see 3D images. Now, of course, you know this is a matrix of bacterial community. Okay, the 3D images. What are the two microscopes can see 3D images? Laser confocal microscope. What other one? Scanning electron microscope. Okay? So that's what you're going to do to review. So, okay, now let's go back to it. There are lots of questions we can talk about that. Go back to C. Go back to right on the top. Okay. Question 12. Resolution decreases when the wavelength of the illuminating light decreases. Is that true or false? This is, we go back to see this old formula. RP equals lambda divided by 2mNA. You need to know this one. So when you do this question, write the formula on the right. Resolution decreases when the wavelength decreases. Is that correct? This is decreasing. So, true or false? This is not a very good question. It's a very tricky question. Resolution actually increases. So this question, you could write true or false, both have a story behind it. Okay? Resolution decreases, resolution value decreases. But the resolution capability is increases. Okay, so you can write true or false. Either way, it's given you 1 point. That's for you to think about. Okay? That question didn't design very well. The wording has some issues. So what you should do is resolution. What we should do? Resolution value decreases. You can add something that value decreases. Capability increases. So this true or false question at the end of the day is a statement for you to study this formula. Okay? That's what we do. If the objective lens of a microscope can be changed without losing focus on the specimen, they said to be. What's the terminology for that? Do you remember in the first lab what's the terminology? Parfocal. What does it mean? Lens stays focused with limited adjustment once it's focused. So, the answer is C. It's called parfocal. Okay. Question number 14. As the magnification of a series of objective lenses increases, the working distance decreased. Is that right? Remember in the first lab, when we draw the picture, it is decreases. So, the answer is B. Okay. So these questions you can study together. We are finding these questions already. Okay, let's talk about these. Question number 19. Because transmission electron microscope use electrons rather than light, it is not necessary to stain biological specimen before observing them. The answer is true. Okay, the answer is true. You don't have to do stain. The technology, what they call it, they call the coating, they call the shadowing, or the other terminology. They don't use stain. So the answer you can do true. Okay? Yes, it is true. Okay, next one, 20. Small intestinal cell structures are best visualized with light microscope, dark microscope, flagellar microscope. We don't have flagellar microscope. Okay, it's just method. So you can cross D at the beginning. Transmission electron microscope. So, what's the good advantage of the transmission electron microscope? We can see the internal structure, is that right? No, what the other one? phase contrast microscope, we can see a brief picture of the internal structure. So you can also go ahead and study. Write a note. If the internal structure one or two microscope can do the observation. Transmission electron microscope and phase contrast microscope. Okay, those are the two we could do the observation of the internal structure. But the phase contrast microscope is not very clear. It's just to give you some idea. And you can go back to look at your chapter number 2. Phase contrast microscope right in the middle. That looks okay. And how about electron microscope? Transmission electron microscope right there, very clear. Okay? And this is another example. See, the internal structure is really good. So that's something you go back to study. We talked about this one already. Okay. There is a kind of a question which is talk about the bacteria media. So I want to give some of the questions, talk about that. Okay. There is a big topic talk about the bacterial media. We want to emphasize that. That's why I said that section is important for the bacterial media. We have several questions related to that. And there is a one difficult question, and I understand it. So we want to explain to you. So there is some topic in here, we talk about bacterial media. So let's look at some easy questions, and we go difficult. Medium containing, let's look at question 36. Medium containing some ingredients of unknown chemical composition is called what medium? First of all, there is no undefined medium. Cross it out. This is the main apple. So B, C, D, you're going to have to pick. This is test tube. Defined media and synthetic media are the same thing. So if you pick C, it will be pick D. So cross them out. You left only complex media. Even you don't know, you still can do it. But you need to know what's the definition of complex media. Because there are some of the ingredients we don't know. Let's say peptone, traptone, is that right? Beef extract, we don't know. So define